In this video, I'm going to take the very useful button presses and software debouncing and put them into a library. So we can use it for many other tasks and videos, because it does take quite a bit of effort to make it over and over again for each video or for each task that we're using the button. This was also a really good comment that one of the commenters recommended that I put it into a library, so we really don't have to see that button debouncing implementation every single time. This video will contain the procedures to create the actual library file itself with the button methods and functions within that library. And we'll also cover doing multiple buttons, so you can pass into this these functions which button we like to test and to determine which one we've pressed. So let's get started. I'm going to use the information already on the NewbieHack website. You can see that in the NewbieHack Microcontroller tutorial, software debounce, and you'll see one of the programs we have here that has a program that pretty much takes care of all of the button debouncing. I added a couple lines. One was release confidence level, resetting it after it's sort of found or pressed, or when it is pressed. And the same thing with actually this has to change to pressed confidence level to 0, resetting it. That will change. We're going to take this program and we're going to just take it, we'll copy and paste it and put it into a new file within our programmer's notepad. So I'm just going to go to File, New, so we can open up a new file, and we'll make it a C++ file. And we'll just paste it in there. You'll see everything is pretty much to the left side. Something that's really helpful, I changed the actual colors of where my brackets are. It works for different types of containers like parentheses and code blocks. And this allows me to help to tab and tab it so it looks a little bit more hierarchical and easy to read. For instance, if we look at the code block here, we know that we can take this and we can just press the tab, and now we have formatted this a little bit better. To do this, you can go to Tools, Options, and then you have a lot of varying options. You can sort of set up the program's notepad, and I use the Styles or the Advanced. Either one will have the brace match in it, and I just changed. Actually, I used the Advanced. I don't know why they have these two different, but you can change your background, the text color. You can even change the size so they look bigger when you actually select them. But that also changes the line height of all of your lines, so be very careful when you change the size. So this is what the brace match would look like when I click on it. You can change all these things here. So when I click on it, it has those. It's very easy to see. It's very bright, and I know where I'm looking. So I'm going to take these, use these two as a reference, and I'm going to tab those over. So that's good. I can now do this one. Use these as reference. Tab them, and I'll do the rest of it. Let's take this one first. And now everything seems to be tabbed quite nicely. We can kind of read it a little bit better. And we need to include our standard include file. AVR io.h. I think from now on, when I make these videos, I'll probably just create a library for everything that I do, or the more useful things, I guess, that I would need to use. Since this is a library file, we really don't need the int main. And we don't need all of this other stuff either. This is just for specific applications. This is data direction for certain pins and setting the pins high or low. So I'm just going to go ahead and delete that. We also need to make sure that we don't run the actual file more than once. So I'm going to use an if and define or if and def statement. Well, actually, you know what? I want to save it first as a specific file name. So let's say, what should we call this? Let's call it button pressed, or I'll put button press. Button presses seems like a a good name for the library for button presses. So I'll save that. I should have saved that as a .h file because this is what the library will be. It's a header file. So let me save that as a header file. I could actually take this out right now. Let's delete that. Alright, now save it as buttonpress.h. Save. As I noted earlier, this has to actually be this, and I'm going to change that in the website. So when we get to the release confidence level, if we actually have the button released, then the pressed confidence level really needs to be reset. It needs to be 0. That will make our whole routine much more efficient and usable. So let's go ahead and define this as the button press include file. So this is essentially the name of the file, and we'll just call this area the button press. I'm just defining button press as a line here, and what this will do is it'll make sure that this is only we're going to put a condition here to make sure that the button press is only used once or loaded once when the compiler compiles it. So if ndef button press, and at the end we need to end the condition. So end if, and this is a special sort of if statement that is used for defined statements. So if this is defined once, and if I asked for this to be included in more files, since it's already included once, it doesn't need to be included more than once. So what it does is it bypasses it. If not defined button press, then it will go ahead and run all this, and it will also run this statement here. So now it's defined. The next time if it has to go, if it gets loaded again, it'll say if not defined button press. Well, it was defined before, so then it will just bypass all of this and not run any or not load any of this program. We're going to make these, we're going to continue using these variables, and they're going to be global variables, so we're just going to have these put in this location. I don't think it's going to be a problem with that. We need to keep these as ints. This could be a car. It doesn't really need to be a whole integer, since it's really only going to be a 0 and a 1. But we also want to, well, we'll look at that in a little bit. We can take this while loop out because this is actually going to be a part of the main program, not a part of our library. So let's go ahead. This is going to be pretty much our main routine here, and we're going to have to create a function. We need it to return, so we'll need to return some information to inform us that the button was pressed or the button was not pressed. So this is the area actually where that will actually happen. I'm going to keep the pressed 1 here, but we don't need to worry about these port B because we don't know what we're really going to be doing yet. So I'm going to return something, and I'm not really sure what I'm going to return. I think I'm just going to return a 1 if it was pressed. And let me start off by using a return type, and we'll call this function button pressed, and we're going to need some parameters in this button pressed. We'll leave these alone for now, so I'll just create a code block for this overall function. We're going to need a return outside of this. If it was returned here, then we could actually put a return at the end of the statement saying it's returned 0, because it will never get to this point if it was returned here first. So we can just put a return at the end saying that, okay, nothing really, nothing was pressed, so it just returns a 0. Essentially what that means is it was a release. And I don't want to put a return inside of here because it's actually measuring the release confidence level. So I'm just going to say return 0 on the outside of that, just at the end of all of the code. We really only care if it is going to be returning 1 within this statement, this condition. So let's see what we need to have in these parameters. First of all, we know we're going to have different buttons in different locations. We don't want to set a particular pin and a port for this library. We want this to be any port and any pin. So we'll start off by using an unsigned character. unsigned car, and we'll call it pin of button. And I've always really been confused about the bit is clear. I don't know why they use pin B and then 1 as the bit, because this really is sort of referring to the port, and then this is the pin of the port, but we'll work with it anyway the way it is. So we'll need to I don't know why I keep doing that. We'll need to specify the bit as well. So we'll also use unsigned car, and this would be the port bit. We really don't know what else to put in here yet, so let's go ahead and just do a copy and paste of this in here, and then the port bit. So now we essentially can pass in the pin of the button and the port bit, and it will consider that in the condition for all of this code here. Another thing is, looks like I need a parentheses here, is maybe I don't want 500 here. I want to change that number every now and then. So let's add that as something that's passed in. So we'll call that an int because it could be a pretty large number. Hopefully we won't have to deal with that since we've fixed a couple things in our program. And let's call this confidence level, or maybe threshold. I'll just put level. So I'll copy and paste that into this and here. So now we can pick our upper threshold of the confidence level at any number we want, so we can sort of refine that number. So now this code is looking pretty versatile. We have nothing set in stone for any particular situation, so this should be able to work with many applications. Now the one thing we need to do is we need to consider more than one button. So we're going to have to create arrays here. Let me think about what we need to put in here. We definitely need to include something here to pass in the button number or something like that. Let's call it button number. So this is saying let's pass in which button number we want to test. So we could have, like, say 5 buttons. We could say we can pass in button number 1, test button number 1, and it'll give me the 1 returned for that particular button. We're probably going to have to put this in a function as well, the initialization. So I'm going to initialize. Do we need to return anything? I don't think so. We're just going to void init buttons. And we'll also put in some of the port information and pin information here. So let's say unsigned character port, or let's say button port, and unsigned character, and what? Yeah, I don't think I want to do that. We'll do that in the main portion. We'll just say number of buttons. So we'll say int number of buttons, and this can be the place where we specify the number of buttons we're going to be using. So it essentially creates the space we need in memory for how many buttons we'll be using for this array. So first we'll have to, in our main program, we'll have to initialize the buttons in the initialization area that's outside of the while loop, the never-ending loop, and we'll have to call this button pressed in the while loop whenever we need to determine which button is pressed. It's also interesting to note the only reason we need this is probably because of the bit is clear. We may not even need this if we use another sort of a bitwise operation, but I'm going to keep it like this, and this will only be loading once anyway because it probably has that if and if not defined, what io.h or whatever, io. So we'll go ahead and I think that's pretty much it. We'll make our main program and see if our button works. We'll create our main program and set up the ports and pins and the number of buttons, and then we'll test for a button and we'll turn an LED on or something like that. So let's go to our main, and we can start with our include statement, and we're going to do the io.h again, and we're going to include, let's do it with button press.h, and actually I'm going to use void main. I'll probably go back to int void main void. I'm going to go back to int. The reason why I actually use int for the main is because the compiler complains if I use a void. If I do void, then the compiler in the output is going to complain to me, specifying that I'm not asking for a return type. So I'm going to go ahead and put int, even though I'm not going to return. And Let's set up our while, our infinite loop, and then our brackets. You know, I forgot to put in my my prototypes. I'm gonna go ahead and prototype this stuff. Void, and just do a copy and paste. And all I'm doing is copy and pasting, and this is just creating prototypes. So the compiler knows what we're setting up as in functions, just in case we use them in any of these functions. It can know what return type and parameters we're passing. So let's go back to the main, and I'm going to save all the files. Sometimes I use the compiler to tell me what I need to do, or if I have any errors so far. I'm going to go ahead and do a make and see what it tells me, and maybe it sometimes helps me with what I need to do next, or what I should clean up before I start going ahead with something else. I'm going to make. Okay. Oh, it must be in the wrong folder. Alright, see what I did. I spelled this AVR. So let me save that. And let me try it again here. Tools, make all. Yeah, buttonpress.h, no such file or directory. Let me see where this one is saved. Save as. I put it in the wrong folder. Yeah, that's where it should be. It doesn't have the .h, but let me put it in there anyway. Okay, so let's see what happens. Okay, looks like I got at least past that. Now I should, now let's see what I have, the errors in what errors I have in button press. Let me take a look at that. I don't have any semicolons here. So I have to end these statements with semicolons. Let's try it again. Alright, we're getting a little farther. Alright, so apparently with this variable size object may not be initialized, it means that this is sort of a dynamic number, and I can't tell the compiler just a number of buttons and an unstated number into a variable that needs to reserve a certain amount of memory. So even with constant, I'm still not able to actually get this to work. So it looks like I'm going to have to put it into a define statement. So we're going to take this out. Control X. I'm going to put it in the main. See if this works. I'm not sure if it's going to work, but I'll try this. Put a number 2 here, so we know that this is a known number for the compiler. We'll make this void. Make this void. So we're telling the compiler there's nothing going to be passed in. So let's save that. Let's see what happens. Alright. Looks like we got rid of those errors, which is really good. But number of buttons. Looks like that is undeclared. I'm wondering if I have to put that in the button press file. I think I know what I did. I put the define before the include. So let's try putting defines above the include here. Yeah. So we'll define the number of buttons first, and then we'll run the button press in the compiler. So let's see what happens. Yes. Looks like we got rid of that error. Well, that's good. So let's look at the other errors. Invalid initializer. Well, that's obvious because we can't just say equal to 0 for all of the unknown arrays. So let's get rid of the equal 0 here, equal 0 here. Let's save, try to compile it again. Okay, that's good. Unused variable released confidence level. Let's see. Unused. I know what's wrong. We didn't add our button number arrays to these, so we got to do that. Okay. This is to specify which button we are testing at the particular moment. I'm just going to do a copy and paste. And all the past as well. Let's see if I missed any past. Yeah, got 2 of these. So we should have everything here now. Alright, let's save it and try it again. I still have this. It's weird. I think I know why that's happening, and this actually doesn't need to be in a function. This is one of those duh moments. Duh. Alright. So, yeah, that's fine. This is a variable that's being used in this area, so if it's in a function, obviously it's not going to be called or knowingly called to use these. So let's try that again. Alright, look at that. Wow, it all compiled. That's amazing. So let's continue on. Okay, so let's take a minute to review what we've done. We have a prototype of a function, button press function, and we're passing in the button number, which is the particular button number we would like to test or return the status of, the pin of the button, the port bit of the button, and the confidence level threshold of the button. So we have that actually over here. This is our function and code. And what we're doing is we're testing if we're hitting the button. We're making sure that it's a pressed by using a confidence level array. And then if it is in fact was released at one point, it will say it was pressed, and then we'll return the state of the button as being pressed. And then we just do the standard resetting the press confidence level. And we do the same thing over here. We essentially mimic the code we have here. And then if it was released, then we just state that it's released, and we return to 0 at the end. We have these arrays, the pressed array, the released confidence level, and the pressed and released confidence level. These are stated at the beginning, but you can see the number of buttons isn't actually stated. It is stated in the main at the very top. So whenever you're using your buttons and you're using your code for wanting to check the state of the buttons, you're going to have to state whether or how many buttons you're going to be using. And then the next thing I think we need to do now is initialize the ports and bits that we're going to be connecting the buttons to. And we will turn an LED on and off, or whatever we need to do with the buttons. We'll use 2 buttons and see if it's successful. So let's go ahead and get started with the declaration, or the creating the states for the pins. So let's go ahead and let's work with port B, and we'll do the buttons on pin 0 and pin 1, and then we'll do the LEDs on pin 2 and pin 3. So the data direction register for the RB for the first button will have to be, well, we'll go ahead and do both of these buttons at the same time. So let's do this. We'll do an OR. We can actually do equals because this is the first time we're doing it. 1 for pin B0. Actually, it's going to be a 0, isn't it? Because we're input. And then we're going to OR this. Pin B1. So now we're creating input. Another way we would do this is, well, let's go ahead and do it. Yeah. Well, I'll just say this would be the same way as doing. This is the 8th, 7th, 6th, 5, 4, 3, 2, 1. Okay, so this would be a 0 and a 0. So we actually didn't really need to do anything. We're just maintaining that as a. You know what? To make it easier, let's just go ahead and make it this way, because we want to change our the pin 0 is 0 because we want input, pin 1 is 0 because we want input, and that would be the two buttons. Okay, so 0, 1, and then 2 would be output because that's an LED, and 3 would be output because that's an LED. So we have the first pin is 0, second pin is 0, third pin is 1, fourth pin is 1 on the port B. So let's now go ahead and we're not going to change the state. We're going to put the pin, the port B high for the buttons, because we're going to be plugging that into the ground and then to the pin. So let's go ahead and let's start it out at. We'll just use the OR and the bitwise operations. Pin B0 and pin B1. That looks good. And so that's creating these pins to be high, so we can plug the buttons into ground and then to the pin. So it'll be, when we click it, it'll be reading ground. Alright, so let's, we're not going to change the ones for the LED because we're going to toggle them when we test them. So what was the name of the, it was the button press. We'll take this and we'll just copy it over since it already has the semicolon, and we'll just put it in here. And you can see we didn't have to initialize any button stuff, because all we're doing is we're stating the number of buttons as 2, and we're setting up the port pins to act in the way we would need them to act. So let's change this to button number 1, or 0 actually, because it's indexed at 0. The pin of the button will be pin B. This is where I thought it was kind of odd that they should say port B. this is the bit. We're gonna say this is the bit 0 because this is the pin we're using, 0 indexed pin. And the confidence level, let's go ahead and make it a 100, and not use 500, and see how that works. And then we're going to that is the function, but it's going to return something. So we can say, let's say a variable equals this, or we can actually just put it right into the if statement. So actually we don't even need this semicolon. And so if button is pressed, if it returns a 1, then it will do whatever is in this code. And we can say, okay, let's take the pin on port B, let's toggle that LED pin, so it would be pin B2. And then for the next button, Control V, let's see, button pressed, this would be the second button, but it'll also be the second pin. It's just a coincidence that this is the second button, and then button number 1, this is button number 0, and it would be the pin number 1. I could have made this pin 5 and pin 6 if I wanted to, but these would still say the same. So I don't want you to get confused in the way I'm doing this. And you can have this doesn't have to equal the same thing. You know, I can imagine some comments coming back. Why are these two the same? And do they have to be the same? No, they don't have to be the same. And we can get into we could use port D or port E if we're using the 128, or port C if we turn off the JTAG use of that port. Well, don't let that confuse you. The port B or even port A we could use, and then we could have different numbers here, and these would still be whichever button we want to test. Okay, so let's do this to pin B3, and we should be good. We don't actually need these. These are actually overkill. I could just put these statements right after the if, but I'm going to keep them in there just for the heck of it. So let's see what else we need to do. I'm going to go ahead and make all. Let's see if we got any errors there. I'm going to bring this up here, and it looks like we do have some errors. 12 is not a function. What is that? I see. We did not put a semicolon after, and that would be probably number 12, I guess. I don't know. I could probably pull that up. 12 is not a function. So let's try it again. Alright, so we need more semicolons. I'm being a bad boy, not putting in my semicolons. Now let's try this. Aha, it worked. Not necessarily working in the chip, but I'm gonna see what happens when I do. It may not work. We'll find out. I have programmed the microcontroller, and I have a button here and a button here, and I have the LEDs here and here. If I press one of the buttons, you can see one of the LEDs turn on and off, and then I do the other button. You can see the other LED turn on and off. So now we know that we have a very good way of testing the button with or including software debouncing. We have very minimal code. All we have is an if statement. We could actually take these out and bring these up here. Still readable code. We have essentially two if-then statements, or if statements, and we have determining our port state, and we have number of buttons. That's all we really need, and they include to check if the button's pressed or not, and that is including debouncing. And we can do all kinds of programs with very minimal code instead of having to go through all of this in every example that I'm going to create, and whatever code you guys have to create. You could just use something very simple like this, checking for each button press, whichever button it is, and appropriate code inside of the if-then, or in the if statements, and you have very efficient and compact code. Thank you for watching. If you are following along with these experiments or producing successful projects on your own, helped by these tutorials, please let me know using the Contact Us page on the newbiehack.com website. I would like to feature these on the website to benefit and motivate others to join this creative field. Thank you.